Welcome to Pre-Cal Trig. Today is Monday, November 15th. We'll begin by talking about the number E. Now, as you're going through the course content, you'll find your online textbook with lots of practice and lots of material that we don't have time to cover in class. So you should be taking notes. We will have one more opportunity to turn in notes for extra credit, but that's it. If you haven't turned in your notes for Units 1, 2, or 3, it's too late to do that, so I want you to focus on Unit 4 and really get ready for that Unit 4 test, because your test way heavier than anything else, and you want to put all of your effort into preparing for those unit tests. I'm not saying not to do the other assignments. Those are important to practice, to build on your learning so that you are prepared. So stop the video, take a few minutes to look at these, scan these QR codes in, and then take notes, and then move forward when you're ready. As you go into our course and look at the announcements, and again, I want to remind you to do this daily because things may change, and it's just easier for me to put that announcements to everybody here in the course. Don't neglect to go into the course materials. So for our agenda this week, today you're attending live class and attempting your first attempt on Unit 4, Lesson 8 quiz. You should correct any mistakes, come to office hours or schedule a help session, and then attempt your second opportunity on your quiz tomorrow. Then on Wednesday, the third attempt is due by 11:30 p.m. I'm going to begin working on a video review that you can start looking at, even though your Unit 4 test is not due until we come back from the Thanksgiving holidays. So continue on Thursday and Friday, catching up on missing work, coming into help sessions, scheduling those help sessions, and getting caught up on anything that you're behind on in this class. I've left that time open for you to get things done. Look at the course announcements for the Unit 4 review later in the week. I hope to have that done by Friday. Our spotlight this week is on Unit 4, Lesson 8, Solving Exponential and Logarithmic Equations. So let's start with something that we do know. Think about exponents and recall the one-to-one property. If we have a number raised to a power of x, such as 2 to the second power, and we say that's equal to 2 to the x, what we're really saying is that this number, x, is equal to this number, 2. So we say that x is equal to y. Now the logarithm is the inverse of an exponent. So the one-to-one property of logarithms states that if we have a log of base b, x equal to the log of base b, y, if and only if x equals y. So we have the same property that we can use to set up equations and solve for x. So we're going to use the one-to-one property of logarithms that we stated earlier to solve this equation. We have log base 3, so we have the same log with the same base. We can say that x plus 2 is equal to x squared plus 4x minus 2. And then we work on solving that equation for x. So we want to move everything to one side. I'm going to switch sides. Okay, and I'll have x squared on the left plus 4x minus 2. And then I'm going to take this side and subtract x and subtract 2 so that we end up with 0 on the right. So we'll subtract x and subtract 2 and get everything over on one side. And our goal is to have this coefficient of that highest power term be positive. Alright, let's put together negative x plus 4x is 3x. And go ahead and write that x squared plus 3x, and then put your constants together. A negative 2 plus a negative 2 is a negative 4, and that's equal to 0. Alright, now we're going to factor this, and it's pretty easy to factor. We'll take that negative 4 and make a table, a t-chart. I want two numbers that multiply to give me a negative 4 and that add to give me a positive 3. So it's either going to be 4 times a negative 1 or negative 1 times a positive 4. Let's take a look at that, and let's add these first two. Ooh, that's just exactly the same thing. Let's make this a positive 1 and a negative 4. Alright, add these two together and you'll get a positive 3. Add that second row together and you'll get a negative 3. And if you look back at our equation, we're looking for a positive 3. So these are the two numbers that we'll use to factor our trinomial. So it's going to be x plus 4 times x minus 1 equals 0. Set each factor equal to 0 and we'll get x equals negative 4 and x equals positive 1. Alright, take a minute to look at that and then test each of these by putting them back into your equation to see if there's anything that's extraneous, anything that we need to omit. Alright, we'll move on to the first problem that I want you to try on your own. So we'll start by setting up the equation. If you'll look here, we have log base 3 and log base 3. So we can set it up as x minus 1 is equal to x squared minus x minus 9. Alright, we're going to move everything over to one side. So I'm going to subtract x and add 1 to this side. So that ends up being 0 over here. And we want to subtract x from this side as well. And then add 1 to keep this equation balanced. Alright, so bring down your x squared. Negative x plus negative x is negative 2x. And then negative 9 plus a positive 1 is minus 8. Now let's work on factoring this. And it factors into x minus 4 times x plus 2 is equal to 0. We'll set each of these factors equal to 0 and solve for x. So the first solution is x equals to positive 4, and the second solution is x equals negative 2. So we have two solutions here. I mentioned this briefly in the previous slide. We want to plug those back into the equation, toss out any extraneous solution. Because you see I have a solution here, and I have a solution here. But we always need to go back and check. Alright, so I'm going to look at that negative 2, and because we're squaring, can you take the square root of a negative number and end up with a real solution? And the answer is no. So we're going to toss out any negative solution as extraneous. So our answer is C, x equals to a positive 4. Let's try another one. And we may have to use some of our properties of logarithms to simplify. So if you look at this, we're adding log base 2 of x and log base 2 of 2x plus 3. So our properties from our previous lessons that we've been going through, and if you need to go through and practice to get more familiar, if you haven't completed those, just slow down and take your time and then go back and practice, practice, practice. Alright, if we look at this and we're adding, remember we can take log of the same base, that's log base 2, and we'll be multiplying these two numbers together, x times 2x plus 3. On the right hand side we have 1, nothing to simplify there. So take your time and distribute 2x times x is 2x squared plus 3x. Okay, so we have log base 2, and I'm going to change the color of my pen to show you. We're going to circle around, and we'll start with 2. 2 to the first power, recall how logarithms work, is equal to this number here. Continue to circle around. 2x squared plus 3. Okay, now I can toss that 2 to the first power, that's just 2, and then subtract 2, hold on, this is 3x, I forgot to bring the x down. Subtract 2 from both sides, so we have 2x squared plus 3x minus 2 equals 0. Okay, now we're going to work on factoring. However you factor that out, and there are several methods, but we won't take the time to explain how to factor. It should break down into x plus 2 times 2x minus 1 equals 0. Set each factor equal to 0 and solve for x, and you'll get these two solutions. We'll go back up to the top. X equals negative 2 and x equals 1/2. We'll toss out this negative 2 because again we're dealing with squares, and take the square root of a negative number and it gives us an imaginary number. We don't want that. We just want this real solution. X equals 1/2. Okay, so I broke this down for you to look at. Again, my writing gets a little bit messy on here, so there are notes for you to keep. Alright, let's try another one, and we're putting everything that we've learned together into these problems. Now this time we have log base 3. Log base 3. How can we simplify this before we start? Take a minute to look at that. Pause the video if you need to. What I'm going to do is I'm going to take this minus log base 3 and I'm going to add it to both sides. So I have log base 3 x minus 6 plus log base 3x equals 3. Alright, use your properties of logarithms. And the properties that we're looking at here is we're adding the logs with the same base, so we can multiply x times x minus 6. So we'll get log 3 x times x minus 6 equals 3. Distribute that x, we get log base 3, x squared minus 6x equals 3. Alright, now let's do our circle around. Let me change my pen color again so you can see it. We'll start with 3. To the third power. Remember, with logs, this number is always going to be our power. Equals, keep going around, this number here. This number is x squared minus 6x. Alright, go ahead and expand 3 to the third. That's 3 times 3 times 3, or 27. 3 times 3 is 9, times 3 is 27. And then we have 27. Let's go ahead and subtract that from both sides. We have x squared minus 6x minus 27 equals 0. Alright, we want to factor that. And we can factor that into x minus 9 times x plus 3 is equal to 0. Set each factor equal to 0, and I'll pull this back up to the top again. We have x equals 9, and we have x equals negative 3. We want to toss out that negative 3. Our solution is x equals 9. Because we're dealing with, let me go back and find it, we're dealing with a quadratic. If we take the square root of a negative number, we get an imaginary number, and that's going to be extraneous. Alright, now we have a word problem. Now it may take you more than 2 minutes if you don't know the formula. So we're going to start off with the formula for compound interest. If you're taking a finance class, anything that's dealing with money and finance, then you may be familiar with this equation. But for most of us, we're not. And the equation is going to be P times 1 plus R over N to the NT is equal to our accrued amount. Alright, so there's a lot there. We kind of need a key. So A is equal to our accrued amount, and so we're looking to accrue $8,000. So we'll plug that in here. P is equal to our principal, or basically what we start off with. So $5,000 times 1 plus R over N, and our rate is 0.14. That's what R is. I'm very carefully making sure that I get everything in here right. 1 plus 0. If our rate is 1.14%. Okay, change that to, that's percent. Change that to a decimal, go back here 1, 2 places, the decimal's going to end up here, 0.014 over N is the number of, how do I say that, the number of increments that we have. So we're compounding monthly, so we have 12 of those increments. Okay, I think I have that right. Let me just double check. All right, and so what is NT? Remember, N is the number of months, and T is our time. We don't know that. That's our variable. That's what we're looking for. All right, so we have everything filled in. You can go ahead and add these two numbers together. You can divide 0.014 by 12. And so I end up with, I'm running out of room, so let me just go ahead and do some of the math. You can divide this 0.014 by 12, add it to 1, multiply by 5,000. So we end up with something like this. 1.001167. We're raising that to the 12t. And that's going to equal to, now what I did is I took this $5,000 and I divided both sides by 5,000. So all that we're dealing with right here is what's in parentheses. Now we get rid of these zeros, divide 8 by 5, or you can divide 8,000 by 5,000, and we get 1.6. So now we have this equation when we simplified it, and we're going to pull this into logarithms. So we're going to find the log of both sides so I can solve for t. Okay, so we're going to say 12t times the log of 1.00167 equals the log of 1.6. And we solve for that, and we get 33.6 years. Again, look at, I don't have enough room to write on this slide, so look at the notes in the PowerPoint, and all of the work will be done underneath each slide. All right, but that's basically how to set this equation up. Once we have it set up, because we have that variable in the exponent, we've got to use logarithms, which are the inverse of exponents. All right, now we're going to go in the opposite direction where we talk about half-life or decay. So we have a sample that originally contains 21 grams of radioactive isotope. After 45 days, 17.3 grams of isotope remain in the sample. What is the half-life of the isotope? So a step-by-step explanation is given in the notes of the PowerPoint, but we'll roughly go through it as much as I can on this slide. So we start by the equation A equals AO times E, and then here we have our Euler's number to the KT. Alright, so this is our initial amount of our sample. We want to find the amount of the sample at the time t. So we're looking for t. That's the time taken. K is our rate constant. So what we were given in our problem is the initial amount of the sample is 21 grams. And A, the final amount of the sample at the time t, is 17.3 grams. The time taken t is 45 days, and the K is the rate constant. So we're going to fill in those numbers in the equation. A is equal to 21, E, K times 45. There's an E right there. A is equal to 21 E to the 45K. I'm going to write that with the 45 first. Alright, and so A is 17.3. is equal to 21 e to the 45k. Then I'm going to divide both sides by 21. And so we have e to the 45k on the right, and we have this amount on the left. So from there, I'm going to take the log of both sides, and we're dealing with that e. So I'm going to take the natural log, and then we'll plug that into our calculator. The natural log of 17.3 over 21 divided by 45. You got this. So we'll get t equals 402.98 divided by 12. When we do that, it's 33.58. Hold on. Alright, let me look. We're taking the log on both sides, so I'm going to get my calculator out, scientific calculator. If you don't have one at home, just use Desmos. It does the same thing. We'll take the natural log of both sides, and we'll get, let me write this on the top. We'll get the natural log of 1 over 2. I'm skipping a lot of steps, guys. But again, everything will be in the PowerPoint slides, in the notes. I just don't have enough room here to write everything. And we got a number up here. Alright, so when we get the answer, we plug it in, it's approximately 161 days. That's the half-life of the isotope. Alright, we have another problem that we're going to practice, and we're looking at natural logs, which is just the log of base e. When we have a number that we're multiplying to a logarithm, we do not pull it in this way and distribute it. That's multiplication. We pull it in and we write it as an exponent. So let's simplify this using the rules that we learned in previous lessons. We're going to write it as ln of x plus 26. We'll take that 1/2. Whatever number's here is going to be our power here. Is equal to, now here we have subtraction. Subtraction means division. Okay, so this is going to be ln of x squared minus 16 over ln of x plus 4. Alright, now we've simplified that a little bit. Take a minute to look at it. And we're going to write this right here. Let's go ahead and factor this out. Well, actually, think back. We have the same base in our logarithm, so we can pull this out and then just write our equation. It'll be easier for you just to look at this part. X plus 26 to the 1/2 equals x squared, which we can, x squared minus 16, which we can write as x plus 4 times x minus 4. Go ahead and do the factoring here in this step, over x plus 4. Alright, then this x plus 4 and x plus 4 cancel. We're left with x minus 4 equals x plus 26 to the 1/2. When we raise something to the 1/2, we're taking the square root of it, so I can write it this way. In order to get rid of that radical, we're going to square both sides. And then we get x plus 26 equals x squared minus 8x plus 16. We want to subtract the x and the 26 from both sides. So we'll have minus 26 here, minus x here. This is where I apologize, we just start running out of room. And I'll move up to the top, pull all that up to the top, clean it up, and I have x squared. Remember, on the left I'm going to have 0 because I'm subtracting x and 26 from both sides. Alright, so I have 0 equals x squared, negative 8x plus a negative 1x is a negative 9x. And then negative 26 plus, let me find my calculator, negative 26 plus positive 16 is negative 10. I'm going to factor that into x minus 10 times x plus 1 equals 0. If you set each of these equal to 0 and solve for x, you'll get x equals 10 and x equals negative 1. We're dealing with squares. We're going to toss out that negative 1. That's out. So we're looking for x equals 10 only. Alright, now I have an example of Newton's law of cooling. It's talking about, here's the equation for Newton's law of cooling. So we're going to take that and model it with a cup of hot coffee. Over time, it will cool down to room temperature. Now, the principle of physics governing the process is called Newton's law of cooling. We experiment with a covered cup of coffee, shown that the temperature in degrees Fahrenheit of the coffee can be modeled by this equation. What is the temperature at the beginning of the experiment? At the beginning of the experiment is when the time variable t takes the value 0, because we're at 0 in terms of time. Since f of 0, where am I going to go to write that? Since f of 0 is equal to 110 e to the negative 0.08 times 0. That's just e to the 0. And what is any number to the 0 power? Any number to the 0 power is 1. So that's going to be 110 degrees right here, plus another 75. So when we start the experiment, our coffee is going to be at 185 degrees. Now, the initial temperature of the coffee is 185 degrees Fahrenheit, a little less than boiling water. Alright, so to find when the coffee is 140 degrees, we want to solve the same equation, but we're going to change things, we're going to introduce different numbers here. So to find when the coffee is 140 degrees, we want to solve this equation. So we're going to set it equal to 140. We subtract 75 from both sides, and then we divide. Once we subtract that 75, 140 minus 75 is 65, and then we're going to divide by 110. So we get e to the negative 0.08t equals 65 over 110. By the definition of natural logarithms, we have this. Remember, we go around this way. Or think of it this way: when we first started looking at logs, we took this number and we set up that logarithmic equation. So we're going from here to here. We divide both sides by negative 0.08. That gives us a value of about 6.6 minutes for the coffee to cool to 140 degrees. The same reasoning gives an expression for the time when the coffee is cooled to 100 degrees. Let's look at an example with compound interest. Now we need to find the formula for compound interest. Alright, let me look that up. I don't have it memorized. Alright, the formula is A equal P times 1 plus R over N to the NT. A is equal to the final amount. So this is what A is. N is the number of times the interest is applied per time period. We're compounding monthly. And we're trying to calculate the number of years. So there's 12 months in a year. Okay, that's what N is equal to. And T is the number of time periods elapsed. Alright, so we set up our equation, and we're going to start with 8,000, that's the amount, is equal to 4,000, the amount of principal we invest, times 1 plus the rate is 1.8%. Again, we move to the left 2 places. Put a 0 there, put our decimal here, and add another 0 at the beginning. So it's plus 0.018 over 12 to the 12 to the t power. And that's equal to what is that equal to? Our amount. That's equal to 8,000. Alright, so I'm going to divide both sides by 4,000. It comes out nice to a nice even number. So 2 is equal to, what is that, 1.00. If I combine these two numbers together, I get 1.0015 to the 12t. Alright, now it's time to take the log of both sides. We take the log of both sides. Again, look at your PowerPoint. It'll have all these steps written out. I don't have enough room to finish on this slide, but take the log of both sides. And you'll be able to calculate it is 38.5 years. Again, just written a little bit nicer. Alright, your next steps: finish any course material in Unit 4, focusing on 4.08 this week. Do your practice, and then look for a video that you can start preparing when we come back for our Unit 4 test. Keep trying to get complete assignments and get your grades up. Reach out with questions, or set up help sessions if you need them. And let me fix this. We talked about Cleveland Amory Black Beauty Ranch. I'll be sending out an email over the holidays with opportunities for you to contribute to their ranch, and we'll work on getting this field trip set up for you. I think it'll be beneficial for everybody that's interested. It'll be optional. Everything's optional.